The mean and the variance of a normal distribution is given by mu and sigma square respectively, and the standard deviation is given by what? By sigma. Continuous. So the normal distribution is a continuous probability what? Distribution. The curve of any continuous probability distribution or density function is constructed such that the area under the curve bounded by two coordinates x1 and x2 equals the probability that the random variable assumes a value between x1 and what? And x2. Thus, the normal curve is given by the probability of x1 is less than x is less than x2. So the area under the normal curve between x1 and x2 gives us the probability what? The probability within that interval. So this one is given by the integral of x1 to x2 of the probability distribution function, normal distribution function integrated with respect to what? With respect to x. So this one is equal to, remember this, when you pull out the constants, is equal to 1 over 2 pi raised to power 0.5 times the standard deviation, and then you integrate the part which has variables and which changes, which is equal to integral between x is equal to 1 to x equals to 2 e to power negative a half sigma squared into x minus mu raised to power what? To power 2. So we are able to transform a new set of normal variable to a new set of normal random variable z with mean 0 and variance is equal to what? Is equal to 1. So a standard normal distribution has a mean of 0 and a variance is equal to 1. In order for you to use the standardized normal distribution, you need to transform the normal distribution function, whereby by computing z, which is equal to x minus mu over sigma what? Over sigma. Hence our probability between x is equal to 1, x1 to x2 is given by 1 over 2 pi raised to power 0.5 sigma integral from x is equal to 1 to x is equal to 2 e to power negative 1 over 2 sigma squared into x minus mu squared integrated with respect to what? To x. This one here, when you substitute for x in this, if you substitute for z in the normal distribution function, we shall, for computing the probability between x1 and x2, you shall get 1 over 2 pi raised to power 0.5. Then you integrate between z1 to z2 e to power negative a half divide by 2 z squared integrated with respect to what? To z. The distribution of a normal random variable with mean 0 and variance 1, as I said, is called the standard normal distribution. The standard normal distribution has a mean of 0 and a variance of equal to what? To 1. So if x is a binomial random variable with mean mu is equal to np and variance sigma squared is equal to npq, then the limiting form of the normal distribution z is going to be equal to x minus mu, which is np, divided by the what? By the standard deviation, which is the square root of the variance, which is npq raised to power what? 0.5. So as n becomes big, is a standard normal distribution with which is with the mean 0 and what? And variance equals to 1. So let x be a normal random variable with mean with parameters n and p. For large n, x as approximate a normal distribution with mean mu, which is equal to np, and variance sigma squared, which is equal to np into 1 minus what? 1 minus p squared. Okay, so gamma and exponential distribution. What is a gamma distribution and what is an exponential distribution? Exponential and gamma distributions play a role in queuing theory and reliability what? Problems. This is where they are what? Applied. They are useful in the queuing theory, queues like long lines, for example in a bank or in a print job, and reliability what? In reliability problems. So the gamma function is defined by this expression. So is given by integral between 0 to what? To infinity, x to power alpha minus 1 e to power negative x with respect to what? Integrated with respect to x. For alpha is greater than what? Is greater than 0. A continuous random variable x has a gamma distribution with parameters alpha and beta if its density function is defined by this. Is defined by 1 over beta raised to power alpha rho alpha close bracket x raised to power alpha minus 1 e to power negative x over beta, or 0 elsewhere. The continuous random variable x has an exponential distribution with parameter beta if its density function is given by 1 over beta e to power negative x over beta, or 0 elsewhere, where beta is greater than what? Is greater than 0. So the mean and variance of a gamma distributions are, the mean of a gamma distribution is given by alpha beta, where alpha beta and the parameters, and the variance is given by alpha beta squared. The mean and variance of the exponential distribution is given by the mean is equal to alpha and the variance is equal to beta squared. Remember, they can give you the question on a gamma distribution and they can ask you to get the mean and the variance, or for an exponential distribution and they can ask you to get the mean and the what? And the variance. So you use this formula and this formula respectively. The gamma distribution has its importance in waiting time. There are problems of waiting time. For instance, waiting time to be served in a bank, waiting time to be served in the clinic, and so forth. So such problems, the gamma distribution is what? Is applied. And reliability theory. There are instances where the gamma distribution works very well, though there is no clear Poisson process in survival time what? Problems. So these instances are very important to note where the gamma distribution works very well if the Poisson process is not clear in survival time what? In survival time problems. Survival time refers to time to an event, for example, time to developing a disease, or time to arrival, and so forth. So if in such situation the Poisson process is not clear, then the gamma distribution can work very well in such situations. The chi-square distribution. A continuous random variable x has a chi-square distribution if its density function is defined by 1 over 2 raised to power v over 2 rho into bracket v over 2 times x raised to power v over 2 minus 1 e times e raised to power negative x over what? Over 2 for x is greater than 0 or 0 elsewhere, where v is a positive integer. So the mean and the variance is given by this expression. The mean of a chi-square distribution is equal to v, which is an integer, positive integer, and the variance of a chi-square distribution is equal to 2v. Remember, the chi-square distribution is also one example of a continuous probability distribution. The beta distribution. The beta distribution is defined by this by rho alpha, rho beta, rho alpha plus beta for alpha, comma beta is greater than 0, where rho alpha is a gamma is a gamma function. So the gamma distribution is the product of rho alpha times rho beta divided by rho alpha plus plus beta, where rho alpha or beta are the or rho alpha plus beta are are gamma functions, So a continuous random variable x has a beta distribution with parameters alpha greater than 0, beta greater than 0 if its density function is defined by 1 over beta into alpha beta times x to power alpha minus beta times 1 minus x to power beta minus alpha for x which is between 0 and 1 or 0 elsewhere. And the mean and variance of the beta distribution with parameters alpha and beta is given by alpha over alpha plus beta, and the variance is given by alpha beta over alpha plus beta squared into alpha plus beta plus 1 respectively. The log normal distribution. The distribution applies in cases where the natural log transformation results in a normal distribution. When we get the natural logarithms, the result also follows a normal distribution. Hence, we have a log normal distribution. The continuous random variable x has a log normal distribution if the random variable x has a log normal distribution. If the random variable y equals to in x has a normal distribution with mean mu and standard deviation sigma. Remember, our y is going to be equal to in of of x, and this in of x also follows a normal distribution with mean mu and standard deviation sigma. So if in x is normally distributed, we say that a random variable has a log normal distribution. So the resulting density function of x is given by 1 over 2 pi raised to power 0.5 times change in x raised to power negative a half into in x minus minus mu raised to power 2. Else the mean and variance of the log normal distribution are mu is equal to e to power mu plus sigma squared over 2, and variance is equal to e to power 2 mu plus sigma squared into e to power sigma squared minus 1. The Swedish physicist Walody Weibull in 1939 introduced the Weibull distribution. The continuous random variable x has a Weibull distribution with parameters alpha and beta if its density